problem. Okay, number 9. Let's see what 9 is telling. Oh, yeah. So we're given the center as -3 comma 4 and the radius of 5. And we have to remember the x minus h everything squared plus y minus k everything squared equals the radius squared. And all we have to do is just plug in the numbers. So this is x plus 3 everything squared plus y minus 4 everything squared equals 25. And if we're asked to graph, no big deal. I plot the center, -3 comma 4. And I go 5 units to the north, east, south, west. So I have 3, 4, 5. I have 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's what happens when you don't plan ahead. That's a perfect example. But you understand what I'm talking about. So that's the center. And that's the circle.
So, like, when math is asking to write it in standard form,
That's the standard form. There is no other.
That's it.
There is no other equation of the circle.
So,
There is only one. Yes.
being that it just says write standard form, you don't have to graph that or anything like that.
No,
Just
but
write it.
I'm just saying the actual problem may ask you to graph it.
Okay.
Yes, please. But- Yes, number 7. 5, 6, 7. I see it. Very good. Number 7 is giving us 2 points. And remember, it's the same equation. The equation of the circle and the equation of the distance are pretty similar. So we are given 2 points, -4 comma -4, and we're asked, and 6 -3. And here we're asked to find, is it 5? Oh, thank you. Sorry. So 5 comma -3. And here we're only asked to find the distance, not the midpoint. So then the distance is the square root of x2 minus x1 everything squared plus y2 minus y1 everything squared. And carefully plug them in, x1, yy, x2, y2, because it's very easy to make a mistake when you substitute. So I'll write 5, and x1 is -4. I will write -3, and I will write -4. So let's do this together. 5 minus -4. How much is that? 9 squared. Very good. Plus -3 minus -4. -3 plus 4. 1 squared. That's it. And that's the distance.
That's why the 2 answers. The first answer is going to end up like that. They might ask you to actually get the actual decimal form. So that's why it has the 2 there. So it didn't want to work out well as you wanted it to.
Okay, next question. Anything else that you would like to continue with?
Should we do number 8, the midpoint?
Yes, the midpoint. The midpoint, remember, is just the average of x values and the average of y values. So we have -4 comma -7, -1 comma -8. So the midpoint, you add the x values, which is -5, and write -5 halves. You add the y values, you get -15, and that's all you need to do. It's the average value, the average of those two. $14. Let's continue with 14. Very good.
Why is that ridiculous?
That's the formula, the average. The average of two numbers, it's okay. The average of two numbers is the sum of the numbers divided by 2. The average of 3 numbers is the sum of 3 numbers divided by 3. Yeah. 14, 14, 14, 13, 14. 14. Yeah. The puzzle that we just looked at. So we have x plus 7, x minus 9, over x plus 5, less than or equal to 0.
What number is this?
The last one.
That's why I didn't know my answer.
No worries. So x plus 7, x minus 9, x plus 5. And of course, you know me, I ran out of room, so I'm going to say ratio. So, of course, if you find an easier method for you, please use it. I'm fine. The method in the book is asking you to plug in numbers. I think that that problem with that method is that you may or may not know when to put a bracket in the answer or a parenthesis in the answer. That's the only thing that I'm concerned about. So that's why I don't use that method, but of course I accept it.
This method is easier.
I think it's easier and it's just, quick, but, Good. So please give me the numbers from left to right, the x values that we need to put in the table from left to right.
-7.
Correct?
-5.
Very good. So for x plus 7, we have 0. For x minus 9, we have 0. For x plus 5, we have 0. What happens with the ratio? Careful. When x is -7, this is 0. The ratio is perfect. When x is -5, this is 0. Very good, awesome. And when x is 9, this is 0. Perfect. There is no discussion, no difficulty here. All of them are linear functions with positive leading coefficient. So they have to come, as we know, from -infinity, go to positive infinity. So 3 negatives. That's okay. 2 negatives. Good. 1 negative. And no negatives. So now I'm asking myself, what do I want to pick? And there is only one answer correct, yes, negative. So negative is here, and I go up and read the x values because I'm solving for x. That's why x is what I'm interested in. Which x will I pick for this expression to be negative? And the answer is between -infinity and -7, bracket at -7, but open parenthesis at -5 and bracket at 9. Becca, is this okay?
So we want less than or equal to 0.
Yes.
So the 9 would be
Yes, bracket. Just this one will be parenthesis. So this is a bracket, union, -5 to 9, and a bracket. At -5, I cannot put a bracket because it's undefined. Good, very good. Anything else? What about number 2? I get to choose one, right? The square of x minus 5 divided by x minus 8. We have had several of these, so please review the problems we did in class right after test 1 till today. All of them, please. Okay, so we're asked to find the domain of this function. So I see 2 problems potentially. This is one potential problem, and this is potential problem. What does this mean? Very good. X cannot be 8. What does this mean? Remember the graph of the square root of x. We graphed the square root of x many times in transformations. Remember the graph and remember what is the domain. And then remember what transformation would you use to graph the square root of x minus 5, and then you would figure out the domain with no difficulty. So you have to have that picture in your mind.
Does the domain for x minus has to be greater than 0? Or is it greater than 5?
It has a transformation in it. We're not looking at the square root of x. The square root of x is domain greater than or equal to 0. This is a totally different function. It's based on the square root of x, but it has a transformation in it. So what is the domain then? Correct. Yes, x has to be greater than or equal to 5. So remember this, for this to exist, I have to write x minus 5 greater than or equal to 0. No matter how many times, in general, it's not you. In general, I talk about the square root. Maybe one student per class remembers the domain. I'm not sure why. Because it's not a difficult function, I think. So anyway, we have 2 conditions. X cannot be 8 and x cannot be, it has to be greater than or equal to 5. Do we understand the 2 conditions? Everyone? Yes? Okay, perfect. So then if you graph, there is no need, but I think it's easier for me to explain. Greater than or equal to 5, this is 5. But this one says not 8. Not 8. So then, therefore, the domain of function g will be,
Bracket 5
yes,
to
yes,
8 with the parentheses.
yes.
And then from union 8 parentheses to infinity.
Great job. Thank you. Great job. Is this clear? So I hope now that since we use transformations on the square root of x minus 5, on the square root of x to get the square root of x minus 5, now it's going to be easier for you to identify the domain. What would you say that?
Well, I think too, even though you say it have to, like, if you were to ask me by looking just at the x cannot equal 8 or x squared equal 5, I probably wouldn't be able to say it, but when you drew it, the way you did on that number line, it made it look much easier.
Yeah, because you see that there's a hole in there because I have the domain for the top between 5 and infinity, because this is the square root of x, but I have to shift it 5 to your right.
Yeah.
So therefore the domain starts at 5 to infinity. But there is a problem because if I include 8 and not exclude it, in other words, if I include it, then the denominator could be 0, and then the whole thing collapses, it's undefined at 8. Good. Any questions on this?
Can we do another one with
Did you know the one with the 112? Or the one with
Which one?
The leading coefficient test?
Graphing polynomial functions?
Whatever number 12, for number 12.
Number 12. That's it. Very good. So let's look at number 12. So we have f of x equals negative x to the 4th plus 25x squared. Becca, is this what you meant? You want the rational inequalities? No. Okay. I hope you remember what you wanted. So this is a polynomial function. We know that. What is its degree? How many possible number of turns? 3. 3 max turns. How many x-intercepts? Absolutely 4 x-intercepts. Great job. So let's find them right away before we start the table. So the x-intercepts are determined when f of x is 0. Negative x to the 4th plus 25x squared equals 0. You know what I am going to do next.
Divide by negative.
Multiply by negative 1 or divide by negative 1, but not divide by x squared, correct? Be careful. So multiply both sides by negative 1. So x to the 4th minus 25x squared equals 0. And then I have to, yes, of course, x squared minus 25. And I have to continue. Very good. And now you're going to give me 4 solutions. Very good. X equals 0 multiplicity. X equals 5 and x equals negative 5 multiplicity 1, 1. So what does this mean? Multiplicity 2 for x equals 0.
It's got to touch the x-axis.
Perfect. What does it mean for these? Slow or regular? Regular. 1. Multiplicity 1 is not slow. Very good. I didn't mean that. So we're going to put 0, 0 and right turn. We're going to put negative 5, 0 and 5, 0 and right cross. I only need the symmetry and I need the end behavior. You said degree 4. Degree 4 means this or this. This or this. It's degree 4. This or this. But the leading coefficient is negative, which means excellent. Great job. The table is done, but now I have to determine symmetry. I have to find f of negative x. So let's plug in negative x to the function and see what we get. The original function is this. So negative x to the fourth plus 25 negative x squared. This becomes very good. This becomes, it's squared. So then f of negative x is negative x to the fourth plus 25x squared, which equals or does not the original function. It does. So it's an even function, symmetric with respect to
y-axis.
the y-axis. Great job. Good. So we are ready to graph. I only need my table. I don't care for anything else. Nothing else matters. We summarized everything here. I plot the points first. I have negative 5, 0. And 0, 0, and 5, 0. Okay, so let's identify the situation here. From negative infinity, it crosses at negative 5, 0, has to turn because it comes back at 0, 0, and it turns again. And then crosses at 5, 0. One more time. From negative infinity crossing at negative 5, 0, it has to turn because it comes back and turns again at the origin. It must turn again because it comes back and crosses at 5, 0. So whatever I graph on this side, I have to copy on the other side. It's hard for me to have the exact same graph, so my apologies, it's not going to be perfect. I'm not sure why I can't make it perfect. So of course this height has to equal this height, mandatory. And this x value must equal this x value. So this is the f of x, negative x to the fourth plus 25x squared. And I have to determine those local max and absolute max to be exact. So in y equals, clear everything and put in negative x to the fourth and then plus 25x squared. Do I want to use a standard? No. I want to change the viewing window from negative 8 to positive 8 with a scale of 1. It's okay. Y minimum I don't really care for. I'm going to say negative 2. It's good enough. But Y maximum, look, ooh, it's all the way up there. So I have no idea. I'm going to say 50 with a scale of 5. Maybe, maybe not. It may not be enough. And it's not. But at least we're going to change it in a minute. It's crossing at negative 5, 0. It goes to a maximum, comes back and turns at 0, 0 as we knew. Goes to another maximum, the same value, comes back and crosses at 5, 0, going to negative infinity. So I have to go back and change the viewing window. And this time I'm going to write 100. I don't know, maybe it's 400. I have no idea. So with a scale of 10. Let's see if that is good enough. It may or may not. It's not. How much? Okay, 200 it is. So that's 200 with a scale of 50. And let's see what we get. Perfect, thank you. So it's crossing at negative 5, 0, goes to a max. It's completely symmetric with respect to the y-axis as we knew. It turns at the origin, comes back and turns, crossing. So I want to determine just this, between negative 5 and 0. So second in calc, it's a maximum. I want item 4. Between negative 5 as the left bound and 0 as the right bound. And I don't want to guess, just give me the max. So negative 3.54. And the maximum is 156.25. Can anyone give us the other one? So negative 3.54 and 156.25. Can anyone give us the other max? Right, of course, because we knew that. Why? Because of the symmetry, exactly. Otherwise, we would have had to determine the other one separately. Very good. That's why we study symmetry, so we can understand these situations. I know we have 2 minutes left, but let me know what else you would like to look at. Number? Number 1, very good. So let's look at number 1.
I knew as soon as it said that. No.
So let's factor the denominator on number 1, please.
X plus 10 is what he's doing.
Very good. So in number 1 we have f of x, 3 divided by, what was it? X minus,
12.
okay, and x plus 10, very good. So then the domain of this function, because x cannot be 12 and x cannot be negative 10, will be negative infinity to negative 10, union negative 10 to 12, union 12 to infinity.